So solve the following equation. The first equation you have here is log x plus 3 to the base 5 equals 1. The second equation you have here is log x to the base 3 plus log x negative 24 to the base 3 equals 4. The next equation you have here is log 3 plus x, but it did not put any base here, so that implies that the base is 10 because this is standard, minus log x negative 5 equals log 3. And the last question you have here is 3 to the power x equals 53. So before I begin to solve, let me just write down something which I'm going to be using to solve these equations here. And that is, you would recall that if you wanted to write a number from logarithm form to exponential form, what we said is that if you're given a number, say log to the base a of x, and let's say this number equals, let's say this equals m. Now what we said is that to write this number to convert it from the logarithm form to exponential form, in other words, this number here is equivalent to, so the m you have here replaces the x you have here, while this x here takes the position of the m. In other words, what you're going to have is going to be a, now your m takes the position of x, while the x takes the position of m. So what you're going to have there is going to be x. So in other words, in the process of changing the logarithm form to exponential form, the powers on the other side of the equation, they change places. So that's a very good way to remember it. Now let's go to the question. The very first question we have here is the log of x plus 3 to the base 5 equals 1. I'm going to write that down. So that is 6. The log of x plus 3 to the base 5 equals 1. Now what I have here is the log of this equals 1, and then to apply what I have here, to be able to solve this equation, the first thing I need to do is to change this from logarithm form to its exponential form. So to change that, 1 takes the position of x plus 3, while x plus 3 takes the position of 1. That is, what you're going to have is going to be 5 to the power 1 equals x plus 3. And this is just the same thing as x plus 3 equals 5. So to solve for 5, you subtract 3 from both sides, and then you have x equals 5 negative 3, which is going to give you 2. So your final answer is x equals 2. The next question says the log of 2, so we're going to write that down too. So that's 7. It says the log of x to the base 3 plus the log of x negative 24 to the base 3. Now this equals 4. Now to do this, let me highlight the powers we have here. You have x and x negative 24. So something you observe here is, since you have an addition sign here, to be able to carry out anything, I'm going to apply the laws of logarithm that says that we can transform the addition to multiplication. So this becomes the log to the base 3 of x. Now the addition here becomes multiplication sign, while you have x negative 24 here, x negative 24. Then this becomes, or this equals 4. So in other words, what I've written here is just the log to the base 3 of x times x negative 24 equals 4. So now you see I have a single number here in logarithm form, and the other side is another number. Now to be able to find x, or to move further, the next step I need to do is to change this number in logarithm form to exponential form. That is this equation here to exponential form. And we said to change this, all we need to do is you switch places. So this takes the place of this, while this moves here. So what you're going to have is going to be 3 to the power 4 equals then you have x negative 24. That is what you're going to have. So 3 to the power 4 is 81 equals, now x times x, that's x squared, minus x times 24, that is 24x. So to solve for x, you can bring 81 to this side, so you have x squared negative 24x negative 81 equals 0. So we want to solve this, and then this is a quadratic equation which we have covered in a previous video how to do this. Now when you factorize x squared negative 24x negative 81, what you would obtain is going to be x plus 3 into x negative 27, and then this equals 0. So when you have this, so this implies that either x equals negative 3 or x equals 27. So you have two answers for this particular question. So that completes the problem for here. Now we go to question 8. Question 8 says the log of 3 plus x negative this equals log of 3. We are going to write that down below because of space. So this is question 8. It says that the log of 3 plus x negative the log of x negative 5. Now this equals the log of 3. Now how exactly do we start this? So again, to highlight this, you'd observe that this is 3 plus x and then this is x negative 5. So what you observe is that you have a negative sign here. Before I begin to carry out any step, I'm going to apply the laws of logarithm that says that we can transform the negative sign to a division sign. Now if it was an addition, you change the addition sign to a product sign. So this becomes the log of 3 plus x. So this is the negative sign, so it becomes division. Then you have x negative 5. So we close this. So this equals the log of 3. So this is what we have. So now note, you observe I carried out my operations without taking into consideration the base. So now note, since the base is not given, anytime you observe that the base is omitted in any equation or any logarithmic equation like this, just know that the base that should be here is 10. So it's a standard, or should I say it's a convention, to always omit 10 when 10 is the base. So this is like saying you have 10 here and then you have 10 here. So let me highlight this. Now you have the log of a number equals the log of another number. So this is as if you're saying this equals this, because you can't have the log of 3 equals log of 5. If the log of a number equals the log of another number, then that implies that this must be equal to this. So this implies that 3 plus x divided by x negative 5 equals 3. So the next thing is we solve. Now to solve this, we cross multiply. So what you have here is going to be 3 plus x equals 3 into x negative 5. Then you have 3 plus x equals, so you have 3x negative, this is going to be 15. So to find x, so we subtract x from both sides and then we bring 15 to the other side, so you have 2x equals, so this becomes 3 plus 15, and then you have 2x equals 18. So divide both sides by 2, so this goes off, then this is just going to be x equals 9. Then we go to the last problem that says 3 to the power x equals 53. Now for the last case, which is 9, it says 3 to the power x equals 53. Our aim is we want to solve for x. Now the thing is that this is an example of an exponential equation. Why? Because the unknown you want to solve is at the exponential position. But the thing is that it is very difficult for us to do anything. Why? Because the thing we want to solve for, that is the unknown that we intend solving, is not at the base level. It should be at the base level. So the best thing to do here is you need to carry out an operation that is going to make this to be at the base level. So what we're going to do is we're going to take the natural logarithm of both sides. So we carry out the natural logarithm of both sides to 3 to the power x equals the natural logarithm of 53. So again, you observe you have three things in a row, so that means we can displace this to this place here. So that's why you have x, the natural logarithm of 3 equals the natural logarithm of 53. So you can see that the reason why I took the natural logarithm is because I wanted to displace the last part here, and that was what I did here by applying one of the laws of logarithm. So now you'd observe that this is my x. I want to solve for x. Now to solve for x, all I need to do is you divide both sides by the log of 3, divide both sides by the log of 3, so this crosses out, and then my x is just going to be the log of 53 divided by the log of 3. So this is your final answer.